So today we are going to talk about similar polygons. Now, last semester we talked about congruent polygons. And if two shapes were congruent, they were what? Same shape, same size. Now remember that the symbol for congruence was the equal sign with the squiggle above it, right? And we said that was same shape, same size, right? Now, if you think about it, same size. A size sounds like an equality, right? Sounds like it's equal, yes? Well, that explains the equal sign part of the symbol. So the same shape must be that squiggle above it. And that's what this is. Similar polygons, similarity, I should say, and we say this. Two figures that have the same shape are similar. And we use the squiggle for similarity or for similar. Now, there's a little bit more. We say that two polygons are similar if, and there are two conditions. Condition 1, corresponding angles are congruent, and 2, corresponding sides are proportional. So two polygons are similar if their corresponding angles are congruent and their corresponding sides are proportional. That way we know that you just can't draw any two rectangles and say, oh, they're similar. No, they're not. They might all be rectangles, but that doesn't make them similar. In that case, their corresponding angles are congruent in a rectangle, but if the sides aren't proportional, then you have a problem. The one thing you should know is the ratio of the lengths of the corresponding sides is the, and you'll hear us talk about this, is the similarity ratio. And that word similarity ratio will come up quite often. All right, let's take a look at this. Quadrilateral ABCD is similar to EFGH. Now, just as a similarity statement, this actually tells us a lot of information. Like congruent statements, we can read from the similarity statements, I know what angles are congruent. Like, give me two angles that are congruent from just this statement. Angle A and angle E. What is angle C congruent to? Angle G, good. Now, at the same time, it also tells us what sides are proportional. So can you give me sides that are proportional to each other? AB and EF are not proportional, they are a ratio. So AB is to EF is the same as what? BC is to FG. Okay? So I can get that out of the similarity statement as well. So that gives us all that information that we need. And of course, as we said, angle A is congruent to angle E, and so on. This is what we could get out of our similarity statements. Okay? If I give you let's say I gave you two triangles. And I'll call this one triangle A, B, C. And we'll call this one D, E, F. And I'm going to tell you, let's see, this angle is 1, this angle is 2, this angle is 3, 3, 2, 1, 15, 12, and 18, 16, 20, and 24. And I want to know, are these two triangles similar? Are these two triangles similar? Well, the first thing is, are all of the corresponding angles congruent? Yes? No? Well, yeah, because angle A is congruent to what? Angle F. Angle B is congruent to? Angle E, and angle C is congruent to? So I do have three sets of corresponding angles. The question is, do the corresponding sides form a proportion? So let's look at this and think about this. In triangle ABC, the side that's 15 corresponds to what side? So AB corresponds to what side? EF. So it's going to be 15 is to 20. Does that equal, let's do 12 to, so what is BC? 16. And is that equal to 18 over 24? And do those actually, are all those, does that proportion work? Well, you could always reduce it too and say 15 over 20 is 3/5. No, 3/4, sorry, 3/4. 12/16 is 3/4, and 18/24 is, so since they're all equal to 3/4, then we have our sides are proportional. So then yes, these two triangles are similar. What triangles are similar? Give me a similarity statement. Triangle ABC is similar to? Triangle FED. Very good. So we could write triangle ABC is similar to triangle FED. Good. Does that make sense? LMNO is similar to QRST. And I'm actually going to draw those out for you. So this is LMNO. And, oops, I don't have enough room up there. That's 2. That's 3.2. And that is 5. And then we have that there, which is QRST. t, and we have 6 and x. And I want to know what is the value of x. What is the value of x? This is a simple question. All you need to do is set up a proportion, keeping corresponding sides together. So I could say, take the x. X corresponds to what side in the other trapezoid? X corresponds to 2, and then I know the 6, and 6 corresponds to 5. And now it's a case of just cross multiplying. X times 5 is 5x. That equals 2 times 6, which is 12, or x equals 12/5. And there's my answer. And so I can use the proportionality to tell me what the missing sides are.